Hello everyone, I'm Khaled Alhomaidhy, and in this video me and my colleagues Naif and Mohammed will be taking you through an experiment we conducted on surface and interfacial tension using the Nouy ring method. We'll start by explaining the concept of surface and interfacial tension, their importance especially in the petroleum industry, and then guide you step by step through our experiment. Let's dive in. First we have to know what is surface and interfacial tension. Surface tension is the property of a liquid surface that causes it to resist external force due to the cohesive attraction between molecules. This force acts along the surface, making it behave like a stretched elastic sheet. And also this explains why small objects like a fly can walk on water without sinking. On the other hand, interfacial tension is the force that acts at the interface between two immiscible liquids like oil and water. It helps explain why different liquids don't mix easily and how they interact at their boundary. Importance of surface and interfacial tension. Surface and interfacial tension are essential in understanding fluid behavior across biology, chemistry, and engineering. Surface and interfacial tension are important in creating stable emulsions, coatings, and detergents, as well as in controlling fluid behavior in a wide range of products. Importance in the petroleum industry. Lowering interfacial tension helps in extracting more oil from reservoirs, making recovery processes EOR more efficient. Understanding surface tension improves fluid flow management, reducing friction and enhancing transport efficiency. Surface tension knowledge helps prevent or manage emulsions, which can impact refining and product quality. Adjusting interfacial tensions can enhance separation processes in refining, improving product purity and process efficiency. And now let's head to the experiment. In this experiment, we are using water and oil as our test liquids, containers for the fluids, a platinum D Nouy ring, a flame gun to sterilize the platinum ring, and finally a tension meter device. Firstly, we'll perform the surface tension experiment using water. The steps are as follows. Use the flame gun to sterilize the platinum ring. Position the sterilized ring securely in the tension meter. Fill the container with the desired liquid. In this case, fill it with water. Place the water-filled container at the center of the tension meter. Carefully lower the ring into the container, ensuring it is positioned at the center of the water. Rest your elbow on the table to minimize any shaking that could cause inaccurate readings. Begin lifting the ring using the tension meter knobs as demonstrated in the video. Record the measurements once the ring detached from the water surface. The results for this experiment is 72.1 millinewtons per meter, which is very close to the typical value for water surface tension, 72.8 millinewtons per meter at room temperature. The slight variation can be attributed to experimental conditions such as temperature, purity of the water, or measurements precision. And now we'll do the same exact procedure but for crude oil surface tension. The steps are as follows. Use the flame gun to sterilize the platinum ring. Position the sterilized ring securely in the tension meter. Fill the container with the desired liquid. In this case, use oil. Carefully lower the ring into the container, ensuring it is positioned at the center of the oil. Rest your elbow on the table to minimize any shaking that could cause inaccurate readings. Begin lifting the ring using the tension meter knobs as demonstrated in the video. Record the measurements once the ring detached from the oil surface. The result is 29.6 millinewtons per meter. This result for oil surface tension is consistent with the expected range for light crude oils, which is typically exhibit lower surface tension compared to water. Now we'll perform the experiment to measure the interfacial tension between water and oil. The steps are as follows. First, sterilize and position the ring on the tension meter like the previous two experiments. And then add water to the container. Place the water-filled container at the center of the tension meter and carefully lower the ring into the water. Pour the oil gently above the water to create an interface between the two liquids. Rest your elbow on the table to minimize any shaking that could lead to inaccurate readings. Begin lifting the ring using the tension meter knobs as demonstrated in the video, and lastly take readings. The result for interfacial tension between water and oil is 21.3 millinewtons per meter, which indicates a moderate interaction between the two liquids. This value is important because it reflects how easily the water and oil can separate or mix. Now we'll talk about the effect of surfactants on surface and interfacial tension. Surfactants like Triton play a crucial role in modifying the surface and interfacial tension of liquids. When added to a liquid, surfactants reduce the surface tension by disrupting the intermolecular forces at the liquid surface. This makes a liquid more wettable and allows it to spread more easily over surfaces or mix with other liquids. For example, in our experiment, after adding Triton to water, we observed a reduction in surface tension from the typical value of around 72.1 millinewtons per meter to 33.1 millinewtons per meter. This significant decrease demonstrates the surfactant's ability to lower surface tension, enhancing the spreading and mixing properties of the liquid. In a similar manner, for interfacial tension, the presence of Triton reduced the tension between water and oil from 21.3 millinewtons per meter to 1.9 millinewtons per meter. This dramatic drop in interfacial tension illustrates how surfactant can facilitate better mixing or emulsification of immiscible liquids, such as oil and water. These results highlight the significant role of surfactants in modifying fluid properties, which is particularly valuable in petroleum engineering application, such as enhanced oil recovery, where reducing interfacial tension can improve oil extracting efficiency. Thank you all for listening and watching. I hope this video helped you understand the concept of surface and interfacial tension and how surfactants can affect these properties. Feel free to share any questions or thoughts in the comments section below.